If you place it where the Sun is, it would expand to reach the orbit of Jupiter, a monstrous, completely unstable star that is on the verge of exploding. Betelgeuse, or Betelgeuse, is one of the most powerful sources of radio energy in the universe, emitting more energy than a billion suns. It is a red giant star, significantly larger and more unpredictable than our Sun. When we think of stars, we often picture tiny specks in the night sky, but stars are much more complex. Betelgeuse is far larger than our Sun and has puzzled scientists for years. Recently, disturbing changes in its behavior have caused significant concern among astronomers. Betelgeuse has intrigued astronomers for centuries. It is so massive that it can be seen with the naked eye, especially during winter, marking the upper left shoulder of the Orion constellation. Despite its prominence, Betelgeuse's brightness varies due to its pulsations. It expands and becomes brighter, then contracts and dims. These fluctuations can last from days to months, adding to the star's enigmatic nature. Betelgeuse is about 600 light-years away from Earth. To understand this distance, consider that light travels at 186,000 miles per second. A light year, the distance light travels in 1 year, equates to billions of miles. Despite its distance, Betelgeuse is visible because it is so massive, about 700 times the radius of our Sun. If placed in the center of our solar system, it would engulf the orbits of Mercury, Venus, Earth, Mars, and even Jupiter. Its mass is estimated to be 12 to 19 times that of the Sun, making it an enormous celestial object. The brightness of Betelgeuse fluctuates between magnitude 0 and plus 1.6, meaning it can be up to 1,000 times brighter than our Sun. Its brightness variations are linked to its pulsations. Expanding causes it to brighten, while contracting dims it. Its relatively cool surface temperature of about 3,500 Kelvin gives it a red color, characteristic of red giant stars nearing the end of their life cycles. Betelgeuse's evolution has reached the stage where it has exhausted the hydrogen in its core and is now fusing heavier elements, leading to its massive size and instability. Betelgeuse's surface features dark magnetic spots, much larger and more numerous than the sunspots on our Sun. These spots are regions of intense magnetic fields that hinder the flow of hot gases, resulting in cooler areas on the star's surface. Despite these cooler spots, Betelgeuse is an active and dynamic star, continuing to generate immense energy. The star's eventual fate is a dramatic supernova, an explosion that will mark its end. As it runs out of fuel, Betelgeuse will undergo intense fusion processes, producing heavier elements and expanding further before collapsing. This supernova will briefly outshine entire galaxies, releasing shockwaves and scattering elements like iron and nickel into space. These materials will enrich the cosmos, contributing to the formation of new stars and planets. Astronomers are closely monitoring Betelgeuse, particularly its recent fluctuations in brightness, which may signal an impending supernova. However, predicting the exact timing of such an event is challenging. While it could occur within the next 100,000 years, a short span in cosmic terms, it remains uncertain when this spectacular event will take place. Advanced tools like the James Webb Space Telescope have provided deeper insights into Betelgeuse's behavior. By studying its outer layers and magnetic fields, scientists have gained valuable information about the processes leading up to a star's death. The eventual explosion of Betelgeuse will serve as a crucial moment in understanding stellar evolution, offering insights into the life cycles of massive stars. The death of Betelgeuse will have profound implications for the universe. Its supernova could trigger the birth of new stars in its surrounding region, continuing the cycle of cosmic evolution. The elements released in the explosion will serve as the building blocks for future celestial objects, ensuring that Betelgeuse's legacy lives on. Betelgeuse's story highlights the dynamic nature of the universe. While its death is inevitable, it also signifies renewal, as the energy and elements it releases will contribute to the creation of new stars and worlds. This giant star's life and eventual demise remind us of the vastness and complexity of the cosmos, inspiring ongoing exploration. Betelgeuse's significance extends beyond its potential to go supernova. It also serves as a natural laboratory for understanding the physics of massive stars. Its size, variability, and proximity to Earth provide an exceptional opportunity for astronomers to study stellar evolution in real time. Observing Betelgeuse allows scientists to refine their models of how stars age, shed material, and eventually explode. These observations are not just theoretical. They have practical implications for understanding the origins of the elements that make up our universe, including those essential for life on Earth. One fascinating aspect of Betelgeuse is its historical variability. The star has dimmed and brightened multiple times over recorded history, each instance sparking curiosity and speculation among observers. In 2019 and 2020, Betelgeuse underwent an unprecedented dimming event that was visible to the naked eye. This sparked widespread attention and theories about whether the star was nearing its end. Further investigations revealed that this dimming was caused by a massive cloud of dust, likely formed from material expelled from the star itself. This finding highlighted the complex interactions between massive stars and their environments. The study of Betelgeuse's outer atmosphere has revealed a turbulent, dynamic environment. Layers of gas are constantly being ejected into space, creating intricate structures around the star. These ejecta eventually contribute to the interstellar medium, the vast space between stars filled with gas and dust. This medium acts as the birthplace of new stars and planets, meaning Betelgeuse's activity today will influence the cosmic landscape for millions of years to come. As Betelgeuse nears the end of its life, scientists have speculated about what its supernova might look like from Earth. When it does explode, it will likely be one of the brightest objects in the night sky, visible even during the day. This explosion will provide a rare chance for humanity to witness a stellar death up close, offering invaluable data about the forces shaping the cosmos. It will also be a stark reminder of the transitory nature of stars, even those as massive and powerful as Betelgeuse. Betelgeuse's life cycle also informs us about the fate of other stars, including our own Sun. While the Sun is much smaller and less massive, studying massive stars like Betelgeuse helps astronomers predict how stars of all types evolve and end their lives. For instance, while Betelgeuse will end in a fiery supernova, the Sun's demise will be far more subdued, expanding into a red giant before gently shedding its outer layers to form a planetary nebula, leaving behind a white dwarf. The legacy of Betelgeuse is already etched in scientific history, not just for what it represents in stellar terms, but also for the inspiration it provides. Its dramatic presence in the Orion constellation has been a fixture in human culture, mythology, and science. As we continue to observe and learn from Betelgeuse, it reminds us of the interconnectedness of the universe and the processes that link the stars to planets, life, and beyond. The advancements in technology and instrumentation, such as the James Webb Space Telescope and other cutting-edge observatories, promise even greater revelations about Betelgeuse and similar stars. These tools allow scientists to peer deeper into the structures of stars, revealing details that were once unimaginable. With each new discovery, our understanding of the universe grows more nuanced, shedding light on the mysteries of our cosmic origins. Ultimately, Betelgeuse stands as a symbol of both the grandeur and impermanence of the cosmos. Its impending supernova, whenever it occurs, will not only be a spectacular event for humanity to witness, but will also enrich the galaxy with the materials needed for future generations of stars and planets. As we look up at this brilliant red giant, we are reminded of the ever-changing universe we inhabit, a universe where even the death of a star can bring new beginnings. The story of Betelgeuse offers a profound perspective on the cycles of creation and destruction that define the universe. This star, which has captivated humanity for centuries, plays a critical role in the ongoing cosmic narrative. Its eventual supernova will serve as both a dramatic finale and a foundation for the next chapter of stellar evolution. The explosion will scatter vital elements like carbon, oxygen, and iron into the interstellar medium, enriching the environment where new stars and planetary systems will form. These elements are not just the building blocks of the cosmos. They are the essential ingredients for life as we know it. The iron in our blood and the calcium in our bones were forged in the hearts of stars like Betelgeuse billions of years ago. When Betelgeuse finally collapses, its remnants will continue this ancient tradition, seeding the galaxy with materials that could one day become part of new worlds and possibly even new forms of life. While the prospect of witnessing such a monumental event is thrilling, it also underscores the fragility of our existence. Events like supernovae, though critical for cosmic renewal, release tremendous energy that can have far-reaching effects. If a supernova occurred too close to Earth, the radiation and shockwaves could significantly impact our planet. Fortunately, Betelgeuse is far enough away that its explosion will not pose a direct threat to us. Instead, it will offer a rare spectacle and an unparalleled opportunity for scientific discovery. Astronomers are particularly excited about the wealth of data that Betelgeuse's supernova will provide. Modern telescopes and observatories are now equipped to capture the event across multiple wavelengths, from visible light to X-rays and gamma rays. This comprehensive dataset will allow scientists to study the intricate details of the explosion, enhancing our understanding of supernova mechanics and the life cycles of massive stars. Such insights could also help refine models used to study galaxies, as supernovae play a crucial role in shaping galactic evolution by redistributing matter and energy. Moreover, Betelgeuse serves as a reminder of the dynamic nature of the universe. The changes it undergoes, from its pulsations to its eventual explosion, reflect the ongoing processes that drive the cosmos. These processes are a testament to the interconnectedness of celestial phenomena, where the death of one star contributes to the birth of another, perpetuating a cycle that has been ongoing for billions of years. In addition to its scientific significance, Betelgeuse holds a special place in human culture. Its vivid presence in the Orion constellation has made it a focal point of myths, stories, and astronomical lore across civilizations. For ancient stargazers, Betelgeuse was a beacon of mystery and wonder. Today, it continues to inspire curiosity and awe, serving as a bridge between our ancestral past and our scientific future. As we look forward to the day Betelgeuse transforms into a supernova, we are reminded of the vast timescales on which the universe operates. While the event may seem imminent in astronomical terms, it is a reminder that the cosmos unfolds at a pace that often transcends human lifetimes. Nevertheless,